Trees are one of the most important and overlooked parts of life on Earth. They provide raw materials for construction, regulate climate, store carbon, and contribute to the air we breathe. They've also shaped human development for thousands of years. Everything from early shelters to modern cities depend on them in some way. Right now, there are estimated 3 trillion trees on Earth. That sounds like a lot, but compared to what existed before large scale human activity, it's significantly less. In this video, we're going to break down the different types of trees around the world, the wood they produce, why that wood varies so much in color and strength, how forests like the Amazon actually function, and how much pressure these systems can take before they start to break down. Now, the types of trees and where they grow. In colder regions like Canada, Northern Europe, and parts of Russia, forests are dominated by coniferous trees, pine, spruce, and fir. These trees are adapted to long winters and low temperatures. Their needle-like leaves reduce water loss and help them survive in frozen conditions. These trees also tend to grow relatively quickly and straight, which is one reason they're widely used for timber. In temperature regions like most of the United States, part of Europe and East Asia, you'll find deciduous trees, such as oak, maple, and birch. These trees grow broader leaves during warmer months and shed them in the fall. Because they grow more slowly, the wood tends to be denser. In tropical regions, especially in rainforests like the Amazon, tree growth is driven by constant heat and moisture. There's no true winter, so growth can happen year-round. This leads to a wide variety of species, many of which produce dense hardwoods like mahogany and teak. The Amazon rainforest plays a major role in global climate regulation. It contains hundreds of billions of trees and operates as a large-scale water cycle. Trees release water vapor through their leaves, which contributes to cloud formation and rainfall. This moisture doesn't just stay local, it moves across regions and can influence weather patterns far beyond the forest itself. Because of this, large-scale deforestation in the Amazon doesn't just reduce tree cover, it can disrupt rainfall cycles. If enough forest is removed, the system becomes less stable. There is ongoing research suggesting that parts of the Amazon may be approaching a tipping point where sections could gradually shift toward a drier ecosystem. This kind of transition would reduce biodiversity, lower carbon storage, and further accelerate climate change. Wood color comes from a combination of internal chemistry and age. Every tree has two main types of wood, sapwood and heartwood. Sapwood is the outer, younger layer that transports water and nutrients. It's usually lighter in color. Heartwood is the inner, older sections of the tree. Over time, this part accumulates compounds like tannins, oils, and resins. These chemicals change the color of the wood and also make it more resistant to decay and insects. That's why woods like walnut appear dark brown, while others like maple are much lighter. In tropical regions, trees often develop higher concentrations of these compounds due to environmental pressures like insects, fungi, and humidity. This contributes to the deeper reds and browns seen in woods like mahogany. So the color differences in woods are largely the result of chemical changes over time and environmental conditions during growth. Now, what about the Woods we use in construction. Well, most structural wood used in construction comes from softwood species. Common examples include pine, spruce, and fir. These trees grow quickly, are widely available, and are easier to process than hardwoods. Despite the name, softwood is still strong enough for structural use. It has a good strength to weight ratio and can handle the types of loads typically found in residential construction. Hardwoods like oak or maple are generally stronger and denser, but they are also more expensive and slower to grow. Because of that, they are more commonly used for furniture, flooring, and finishing rather than framing. So while hardwoods are often seen as higher quality in certain applications, softwoods are more practical for large-scale building. So let's talk about the population. Current estimates place the global tree population at around 3 trillion. Before large-scale agriculture and industrial activity, that number was likely between 5 and 6 trillion. That means humans have removed nearly half of all trees over the course of history. Today, deforestation continues at a large scale. Around 15 billion trees are cut down each year, while reforestation efforts add back only a portion of that. Another important factor is forest quality. Old growth forests, which take hundreds of years to develop, are being replaced in many cases by younger managed forests. These younger forests don't store as much carbon and don't support the same level of biodiversity. Now, what about the oxygen and carbon that trees produce/harness? Trees contribute to oxygen production through photosynthesis. A mature tree can produce enough oxygen annually to support a few people depending on its size and species, they say around 4. However, trees are only a part of the global oxygen system. Marine organisms, especially phytoplankton, produce a significant portion of the Earth's oxygen. Where trees are especially important is in carbon storage. They absorb carbon dioxide from the atmosphere and store it into their trunks, branches, roots, and surrounding soil. This process slows the buildup of greenhouse gases. When trees are removed or burned, that stored carbon is then released back into the atmosphere, contributing to climate change. Now, there isn't a single number that defines how many trees we can lose before the system fails. Instead, scientists focus on thresholds within ecosystems. Large forests, like the Amazon, rely on internal feedback systems, things like rainfall cycles and soil moisture. If too much of the forest was removed, these systems weaken. At a certain point, recovery becomes much harder, and the ecosystem can shift into a different state. This kind of shift wouldn't happen instantly, but it would have long-term consequences for climate stability, agriculture, and biodiversity. Trees are a foundational part of the environment and the global economy. They provide materials, regulate climate systems, and support ecosystems at every level. The current challenge isn't just about how many trees exist. It's more about how forests are managed, how quickly they're being removed, and whether they can recover at the same pace. Understanding how trees function and how much we rely on them is a necessary step in figuring out how to manage them long term.